Hi, we are Group Charlie, and this is our project Bit Verified. So suppose you are a whistleblower, and you discover, for example, that the networking lectures are sponsored by Nestle, and you want to leak this information to the wider world. Well, our system provides a peer-to-peer distributed system based on the Bitcoin blockchain for doing that. So since you're a whistleblower, you have some particular requirements. In particular, you'd like to remain anonymous. And this is because we believe that fundamentally you shouldn't have to give up your high-paid job as a government contractor in order to appear in public only via robot, like our friend Edward Snowden had to. And you'd also like to provide some sort of evidence of provenance of your documents. And so we do this in the form of metadata. And this takes the form of a description of the document, a hash, and a timestamp. And you'd also like your evidence to persist, so that when you put something onto the system, it can not be taken off again by another party. So how do you actually interact with our system? Well, you can add a document entry which contains all the things I talked about previously, that metadata. And then you can search through entries that other people have added, and verify that they existed at a time, etc. And if you receive a document, so if you're a journalist and someone sends you this leaked document, you can check its hash and see the entry it corresponds to, and in that way verify that it existed.
All right, so we know that Bitcoin uses the blockchain to distribute this ledger of who owns a Bitcoin at a given time. So we took this idea and we wanted to store the metadata being uploaded by our users. So this metadata is put together in what we call an entry, and these are all formed in a block. And this block also has some other information, like information from the previous block. So together, these form what we call the blockchain. So the blockchain is what really solidifies it and keeps it from being changed. And one of the fundamental rules to the blockchain is that the longest blockchain is known as like the canonical blockchain, since many different nodes are sharing this and they need to agree on which chain is like the chain. So in order for a block to actually be added to the chain, it must be mined. So what it means to mine is it's a computationally difficult problem to verify a block such that the hash of the block meets some criterion that we've agreed on. So this is important because as our system grows, we need to make sure that not one node and one group of nodes agrees that we want to overwrite some person's document that they don't agree with. So since we can vary the difficulty, it means that we can also keep it so everybody in the system agrees that makes our system work.
So Nico's built up an abstraction of we can distribute entries and blocks to people however we like. But since we built the blockchain essentially from the ground up, we also needed to do networking. And one of the big things we learned about this project is that this is really hard. So our networking layer is responsible for distributing blocks and entries, but also doing peer discovery and blockchain synchronization. So blockchain synchronization is if someone goes offline and then comes back online, they can catch up with what's happened while they were away, and also a new node can discover what progress has been made since the start of time. So there are some extensions that we'd like to have to the project. In particular, we'd like to make it more scalable. So currently we assume that all nodes communicate bidirectionally with all other nodes. So we've got O of n squared communication links, which isn't very scalable. We'd also like to implement proof of mining, since there's no inbuilt incentive into our system for people to carry out this computational work. We'd like to have a system where if you do some work, you send out that fact to your peers, and they only distribute blocks and entries to you based on the fact that you've done that. And we'd also like to implement elliptic curve cryptography. So suppose you're sharing an entry privately with someone, and you don't know their uploader ID. So you contact them over the phone and ask them to read out their uploader ID. Since we're using RSA, you're currently faced with a key that looks like that. So you'd have to read that out over the phone, which is not very usable. But anyway, thank you very much for listening. We're Group Charlie. Please vote for us.